stacks today. So when we are appreciating about stacks, we should understand that a stack is nothing but just one of the abstract data types that we have in computer science. It's one of the abstract data types that we have in computer science. So we can just give, we can always mimic or just try to imagine a stack just like a pile, right? Just like a pile of books, whereby we are putting books on top of the other, basically. So a stack in programming can be implemented using an array, right? So we're going to be using arrays to implement our stacks. Basically, stacks, they work with the basic concept or operation of last in, first out. The last element to be added in the stack will be the first to get out. I'm pretty sure that that's simple, right? That there's only one way out of a stack. Elements are going to be removed from a stack depending or based on the way that they actually come in. So if you place an element, like let's say that we have placed an element 1 here, 2 and 3 and 4 here, the first element to be taken out of the stack will be 4, because that was the last element to be added, basically. So the things that you're supposed to be sure of, that you're supposed to be mindful of when talking about stacks, is the part that we can implement them using array, and every stack has got a pointer. A pointer that we're going to be using this stack is the top of stack pointer. So if suppose there is no element in my stack like this, my top of stack pointer will be pointing to nothing. There is nothing that is in the what? There is nothing in the stack right now. So my top of stack will be equal to what? Will be equal to 0 in this situation. Why? Because my stack is empty. But moving on now, when we want to add an element now, that's when we are moving on to the part of the operations that are applied on a stack, or the different methods that we're going to be seeing on stacks. There is push. Push is used whenever you want to add an element to a stack. That's when you use push. Whenever you want to add an element, you will put the element as what? As a parameter, if you want to add an element into a stack. Then the other operation that we have is pop, and pop is going to be used whenever we want to remove an element from a stack. So there is no need of mentioning which element you want to remove. Why? Because we know that stacks only use what? They use the last in, first out kind of logic, whereby we are saying that whenever you say pop, you are removing the last added element into the stack. So there's no need of specifying with the element that you want to remove here. Then there is another optional operation which is called is foo, which checks whether the stack is full or not. So this is basically a function that returns a Boolean value, either true or false, based on the fact that is the stack full or not, right? So check this part now. Let's talk more about these operations now. Whenever I want to push an element into the stack, it is important for me to first check if the top of stack pointer is not already the maximum number of elements that are supposed to be in my stack. When I declare my stack, I'm supposed to be declaring it with the maximum number that it can hold, right? Maximum number that it can hold. So we are saying, if I want to push an element into a stack, I'm first supposed to check if the top of stack is not already pointing to the maximum. You get the point? If I don't have the stack already populated, then if I want to pop, so one condition that I'm seeing here is that whenever I want to push, I'm supposed to check if the top of stack is not already maximum. If it's still less than the maximum, then I can actually add an element and increment the value of my top of stack pointer. But if my pointer now, if I want to pop now, I am supposed to check if the top of stack is not already 0. Because if my top of stack is 0, it's telling me that there is nothing that is in the array, so I cannot remove anything out of it. So pop checks if the top of stack is less than, if the top of stack is not 0 first. If it's not 0, then there is something that is already in the array, in the stack, so I can remove something. Okay, we'll just put these down as their algorithms. But basically right now, if I want to push, suppose that I want to push a number, I want to push letter A like this, I will first check, is my top of stack equal to max here? That's the first thing that I will check. is the top of stack equal to max yangu this time is supposed to be 4. Is it equal to 4 here? Right? So if it's equal to 4, then I'm just going to go ahead and actually say that the array is full. But right now it's not equal to 4, it's still less than 4. Is it less than 4 here? If it's less than 4, like what it is right now, then I can go ahead and add my a. After adding my a, when adding my a rather, I first have to increment the top of stack. You get the point? So right now my top of stack is pointing on 0. So okay, let's just save it like this. I have to put my a. Why? Because my top of stack is still less than 4. The value of my top of stack is actually going to be changing. My top of stack now is now going to be equal to 1. Why? Because I'm saying that there is an element that's sitting now on position number 1. Then I want to push another value. Let's say that I want to push another value, which is b. So if I want to push b, I'm going to be putting b here. After putting b here, I can actually add another element. So my top of stack is now going to be incrementing. Now it's no longer 1. It's now top of stack is now equal to 2. I want to push another value, c. I will first check again, is my top of stack still less than 4? Yes, it is still less than 4. So I can actually go ahead and increment and put c here. And my top of stack is now what? My top of stack is now equal to 3. Then if I want to push another value, d, I can actually go ahead and push another value, d, because my top of stack is still less than 3, it's still less than 4, so I can put d here. Check this part now. When I want to push now a value like e, I'll first check, is my top of, okay, my top of stack was now equal to 4, right? I was now pointing to 4. I'll first check, is my top of stack less than 4 here? Then if yes, I'll check again, is my top of stack less than 4 here? No, it's not less than 4 because it's already equal to 4. You get the point? So I need to get out of this now saying that my top of stack cannot, so I gotta get out now and say my stack is full. I gotta get out and say that my stack is full. That's how I work. That's how the push work. You check first if the top of stack is not equal to the maximum number, then you then increment, you then add an element if and only if the top of stack is not equal to the maximum. But when you want to pop now, pop is going to be coming through a little bit different. When I just want to pop, it's just going to be coming through a little bit simple like this. I can just say pop. If I say pop like this, pop is just going to be checking good up. Is my top of stack here? Is my top of stack equal to 0 here? Right now it's not equal to 0. It's actually greater than 0, so I can just remove the value I'm d. I'll check for if I say pop again, c is going to be removed. If I pop again, b is going to be removed. If I pop again, a is going to be removed. Now my top of stack now is now equal to 0 now. If I then say pop now, it's supposed to be telling me that no, the array is what? The array is empty. Or my stack is empty. Let's have stack here. My stack is empty. That's what I'm supposed to be seeing at the very end of the day. So yeah, that's pretty much as far as the logic on how stacks work is concerned. So you need to be having an array that's going to be acting to be storing your value. You need to have a pointer, a top of stack to be telling us, to be keeping track of which one is which is my top of stack at that point. In this example, 0 means that the stack is empty, but top of stack, if top of stack is equal to 4, then my array is full. My stack is full, I mean to say. You can push into a stack whereby you're adding a value, but you have to check first if the top of stack is not equal to the maximum index. You can also pop out of a stack whereby you are removing elements from a stack, but you remove the elements using the last in, first out. Then is full is just going to be checking if TOS is, if the top of stack is equal to 4 in this example. If the top of stack is equal to 4, then this retains a true. But if the top of stack is less than 4, then it returns false, because it's just a function that returns true or false to verify whether the stack is full or not. As I said, it's optional, but you can make this based on the logic that I just expressed. So the next thing that you're going to be doing now, as far as stacks are concerned, is to probably write the algorithm on how to push into a stack and how to pop out of a stack. But for the meantime, this is the basic logic as far as a stack is going to be operating.